Okay, so today we're going to be looking at factorizing quadratics. And to start with, before we get into the detail of it, I thought it would be helpful for us to look at the difference between two different types of sequences. So we're going to start off with a fairly straightforward sequence. And what I want you to consider is how you would go about finding out what the next number in that sequence would be. Fairly straightforward question. And what you would probably just do naturally is you would look at what the difference is between each of these terms. And you would see, I'm sure, that it's 2. And then you would use that bit of information to find out what the next term, what the fifth term in that sequence would be. And so obviously you would just add 2 onto 9, which would give you 11. That's what we call a linear sequence because it's basically a common difference going up. I'll say that differently, but yeah, basically the first difference is the same in each one of these. So that's a linear sequence. Now what about this sequence here? This time we're going to have 1, 4, 9 and 16. Again, I'm going to ask the same question. How would we find out what the next number in that sequence would be? Well, we can't do exactly the same as we've done in that first example because if we look at the differences, we find that they are 3, 5 and 7. So there's a change in each of them. And so if we then look at the second difference that there is, then we see that between 3 and 5 the difference is 2, and between 5 and 7 the difference is also 2. So actually, although the first difference is changing each time, the second difference is the same. And what we can then do is we can use that to find out what the fifth number in this sequence is. If the difference in this one here is 7, then it must be 9 in the next one because of this second common difference of 2. And then of course after that we add 16 and 9 together, which gives you 25. And there we are, we've found the fifth sequence. Now as I said, this first sequence we looked at is what we call a linear sequence. This second one is what we call a quadratic sequence because there's not a consistent first difference in this one, whereas there is a consistent second difference in this sequence. Now, we can probably clarify what that means by looking at how this would be if we plotted it on a graph. So, if I have a look at this sequence here on a graph, I'm going to use a different colour pen to illustrate this. If we plot this point here, this is our first number, this is our second number in the sequence, third, fourth and fifth, and exactly the same down here as well. So if we look at this first one and I plot that, if we have 1, 2, 3, 4 and 5, then I can plot the points on the y-axis. Remember, this is our x-axis across, our y-axis is vertical. If I plot this, then when x is 1, y will be 3, so that's going to be something like this. When it's 2, we know that our term is 5. When it's 3, it's going to be 7. 4, it's going to be roughly 9, is up there. And 5 would be 11, and you can see that we get a nice straight line, straight-ish line at least. And that's an example of a linear sequence because we've got a straight line relationship going on between the two different variables. Now, if we look at the second one, then it's going to be somewhat different. So again, we're going to have our 1, 2, 3, 4, 5 dotted along the bottom of the x-axis. And on the y-axis, we're going to have these terms. We're going to have when x is 1, our first term is 1 as well, so that's going to be here. When we have our second term, it's going to be 4, which is going to be roughly there. 3 is going to be 9, and then we're going to have a bit of a problem because we can't fit everything else onto the graph. But what we can hopefully see is that we've got something of a curve starting to emerge, if I've drawn that correctly. And basically a quadratic graph, if we were to explore this in some more detail, we'd find out that we end up with what we call in maths a parabola, which basically means that when we get into our negative part of the graph, so -1, -2, -3, we end up with something that looks like that. Okay.